A bridge is to be built in the shape of a semi-elliptical arch and is to have a span of 100 meters. The height of the arc at a distance of 48 meters from the center is to be 7 meters. Find the height of the arch at its center. Okay, so we really need to see this one. A drawing will help. So let me draw a little axis system. This is a good example to see how math works with the real world. Math itself is not real. Math is completely made up, but it's made up with a purpose to help us describe and predict and deal with things that are real. So here's a great example. You got a real-life bridge that engineers are trying to build. They want to make it out of an ellipse shape, the arch. They want it to be semi-ellipse. Semi means it's just half an ellipse. So we're talking about a bridge. Whoops. Let me try that again. We're talking about a bridge that looks like that. Semi means half. So a half ellipse, the top half of an elliptical arch. So a bridge like that, its span is to be 100 meters. So let me put that on my graph. So I'll go here and there. So let's just do it like this. So we're building this bridge. There we go. And its span is 100 meters. So that means it's 100 meters. Whoops. Let me try that again. From there to there. That's the span, right? The width of the bridge, the span. It's 100. The span is 100 from edge to edge. Okay, so that means this is over 50 and this is back 50, isn't it? If it's 100 all the way across. Okay, and now they're saying the height of the arch, like how high up the arch is, at a distance of 48 meters from the center is 7. So if you go 48 meters from the center, you go way over here, let's say this is 48 meters from the center. Right there, the height will be 7 meters. So that's what they're saying. If you go 48 meters, they want to build it. The engineers plan in advance. They say, okay, we need trucks to go under this semi-elliptical arch, and we need to put a highway, and the highway we want it to be able to go 48 feet to the right and the left, and we want a vertical clearance of at least 7 meters. Yeah, not feet, meters. 48 meters to the right and left, and we want a vertical clearance of 7 meters above the arch at the edge of the highway, which would be 48 meters to the right. So they put that in there, and then they say, and then the question is, what's the height of the arch at the center? What's this height right here? This is what they're actually wanting us to figure out, the height at the center. What's the height at the center? That's the question. So when they design this thing, they want to design it so that you have a clearance of 7 meters at a distance of 48 meters from the center. For how wide you want the highway, you want 7 meters clearance over there. Okay. So how are we going to go about this? Well, we write the equation of an ellipse. This is a picture of a half ellipse. Write the equation of an ellipse. You know the equation. What's the center of this ellipse? Well, 0, 0. I made it that way. See how I'm using math, which is made up, to help me deal with things in the real world. In the real world, this bridge is not sitting in the middle of a red axis system, right? I just made that up. There's no real axis system in the world, right? I just made that up and stuck it in the middle of the bridge because that would be helpful for us to solve the problem. See how we use math as a tool to help us solve real-life problems. So I just stuck the axis system right in the middle of the bridge, so the center is 0, 0. So I can just use x squared over a squared plus y squared over b squared is 1. Okay, now what's the a? Remember the number underneath x is how far right and left A is how far right and left from the center. B is how far up and down from the center. So do I know how far right and left? How far from the center to the right edge? Well, that's A, and that's 50. Right? It's 50. So this becomes x squared over 50 squared. Okay. Now, do I know B? How far up and down? No, B's the height. That's what I'm trying to find. B is the height. B's how far up or down from the center. So B is the height we're looking for. That's what they want, right? Find the height of the arch at the center. Find B. So they want me to basically find B in the ellipse equation. That's what we're looking for. That'll be the real life height, is the B in the ellipse equation. How are we going to do that, though? We don't know anything. Well, we do know one really important thing. Do you see it? This is a point. What's the coordinates of that point? Over 48 up 7, isn't it? That dot right here is over 48 up 7. That's the x and y values of that dot on the edge of the ellipse. And remember, anytime you have a point on a graph, any graph, ellipse or any graph, that means the x and the y values plug in 48 here for x, 7 here for y, has to make the equation true. That's what a graph is. That's what any graph in math is. It's a million dots all around here, and all of them have x, y coordinates, and if you plug them in, they make the equation true. That's what a graph is. It's a picture of all the points that make the equation true. So if you have a point on the edge of a graph, you can plug in the x and the y to the equation. It's got to be true. So that means 48 squared over 50 squared plus 7 squared over b squared equals 1. Now I can solve for b. See how b is the only letter? So I can solve that equation for b. So I'm going to do it. I'm starting with the first one here. I did 48 squared over 50 squared. I got 0.9216. And this is 49 over b squared is 1. Let's subtract the 0.9216 from both sides. Bring it down here. We get 49 over b squared. And your calculator on the right side, so the 1 minus that is 0.0784. Now what are we going to do to keep solving? Put this over 1. Remember, when you have a fraction on one side of the equal side, diagonal, you multiply. 49 times 1 is 0.0784 b squared. I should move that down. It's kind of cramped in there. So one more time. 49 times 1, right? I did this diagonal equals, and then this diagonal, 0.0784 b squared. How do you finish solving for b squared? Divide by the 0.0784. 0.0784. And so b squared equals 625. Last step, root it. So b equals 25. That must be the height of the elliptical bridge, the semi-ellipse shaped bridge at the center, because b in an ellipse equation is always how far up and down. B is the height from the center. So, and that's in meters. They want you to give meters because everything in this problem is in meters, and there's the answer. 25 meters. We solve for b. There we go. So make sure you know that for the exam. That's a very good question.